Okay, so we got this thing all waxed up and masked off, and I'm gonna get it sprayed here. So we're gonna go through the difference between red tooling gel, gel coat, and another material you can use, which is polyester primer, polyester high build primer. So let's start this out and let's get going on it. This would be season 2, episode 2, and we're still making the seams for the plug. It's been kind of a redundant process of this same thing over and over again. So let's go ahead and check out our masking, which I can see right here. There's a spot. I got to run the masking across. It's just that still. But yeah, thanks for tuning in, and this is going to be a pretty good episode. We're going to explain again how to keep chemical reactions from happening and the difference in materials you can use and stuff like that. The mill's running in the background. It's going to drown me out. These are the polyester primers you can use when you're doing lamination. You can spray your mold with either one of these. They're both polyester primers. The difference is this quality, like this G2 primer. It's superior product compared to this USC stuff. USC is kind of like the Walmart version of things. This is kind of like, I guess the professional paint shop stuff. I prefer this over anything if the budget allows for it. I use this when I'm making stuff quickly that I know I'm going to throw away, like these seams that I've showed you. We're going to use the black G2. As long as it uses a methyl ethyl ketone peroxide MEKP catalyst system, you can use it and you can laminate over the top of it. You can't use urethanes or epoxies or nothing like that. It has to be a polyester primer. I've seen people try to use the urethanes and epoxies and they've worked, but I haven't seen it function for 10 years. I've seen both of these products function for 10 years on projects that I've done, and they're just what I use because I've been using them forever and I know they're not going to fail. The only problem with these things is that, man, they are so full of fillers that you have to stir it and stir it and stir it by hand if you don't have a paint shaker. I don't have a paint shaker, so I have to sit here and stir it by hand. Anyway, 10% acetone reduction, 10% acetone reduction is the general ideal with any polyester primer. You just reduce it by 10% with some acetone, and then you throw MEKP, a 20-ounce cup like this. You put 15 cc's of MEKP. So fill this up to about right here, I guess. 10% acetone, 15 cc's of MEKP catalyst, and you're good to go. All right, so I've mixed it up. 10% acetone, 15 cc's of catalyst per 20 ounces of polyester primer, and I've strained it again. It's just something I do. I've always talked about it. There's a lot of little particulates in there, and I stirred that can up really, really well. But those little particulates that are in there, the catalyst is not going to be able to penetrate into that and catalyze those. So you'll end up with those little flakes of uncured material in your stuff. I don't know. I just got in the habit of straining stuff a long time ago. I grew up in a body shop, and that's kind of where it started. I see a lot of people not do it and not have problems, but I've also seen it cause problems. So I don't know. I suggest straining everything. Polyester high build primer being used on a plug, just like you'd use red tooling gel or gel coat. Yeah, it's just another product you can use. You can't put it on there super thick like you do with tooling gels or gel coats. Like in the corners, people will spray it in there, it'll beat up. They'll use it as a filler. Some people will put it on there so thick. This stuff, you can't do that, it'll shrink. From the 90s to now, they've made some great improvements on it to where it doesn't shrink as much, but it still will. All right, they're in the background working. I gotta get to work. I'm going to apply the polyester resin to that. I've catalyzed it. This is a 20-ounce cup. It's half full of resin. I put 20 cc's of resin in that, or 20 cc's of catalyst in that. So it's about 10 ounces of resin, 20 cc's of catalyst. I've let it set around for about 5 minutes because it's like 40 degrees in the shop. So now I'm going to coat that polyester high build primer that I sprayed on top of that. It's to keep it from keeping it from developing a chemical reaction. Now that this polyester high build primer is cured and I've coated it with one thin layer of polyester resin, I'm going to go ahead and laminate it with an 1.5 ounce layer of fiberglass mat. Then I'm going to put a 3 ounce layer over the top of it. So in the other videos I showed you, you put your 1.5 ounce down and then I let it cure and then I lightly sanded it and then I put the 3 ounce over the top of it. I only did that to show you a couple things. One is that I wanted to show you what an air ply was mainly, and I wanted to teach you about the chemical reactions that can happen as you're doing this. But this time I'm just going to do them both at the same time. I'm going to put the 1.5 ounce fiberglass mat down, and then I'm going to put a layer of 3 ounce fiberglass mat right over the top of it while it's all still wet. You don't have to wait. Some of the benefits to waiting are, for example, like in these corners like that. If you put your air ply in there and you let the 1.5 ounce cure, just to make sure that you didn't get any drainage and voids, because a lot of the times the resin will drain out of these hard angles on vertical surfaces. So you lay up your 1.5 ounce fiberglass mat, you let it fully cure, and if you do have that, you can take a Dremel and you can go in there and you can Dremel that stuff, the air pockets out, and then re-laminate it. So since this is a just flat surface mainly, I'm just going to go ahead and do both of them. So just to kind of clear up why I was doing the 1.5 ounce fiberglass mat by itself, sanding it, and then the 3 ounce, those are some of the reasons why. But you don't have to wait. Even if you don't want to wait, you don't have to. Now that we've got this laminated with one layer of 1.5 ounce and one layer of 3 ounce, we're going to pull it off of there real quick. And I just wanted to show you guys some other things that's pretty beneficial to know. If this was an actual mold, what I would do is I'd come over here and on this side of this seam, I would put one of these registers, but I'd do the bolt like this, like a self-tapper. I would do it right here in the corner, as close to that seam as I could, to lock that down, because when you pull this piece off, it wants to try to put pressure on this, and it might disturb that if this was a mold, but it's not. I'm going to show you how to do some tricks to not disturb your molding surface with this. Just use this as an example. So for one thing is we don't want to pull from this side first, because that'll want to lift. And if this was an actual part of the mold, it would try to lift that as well. So we want to work the vertical surfaces loose first as we go down it, and we'll get our putty knives and we'll start doing that. Let's not forget to put our register marks in it for the clecos. You getting close to the corners is always a good idea, as close as you can. The tooling or drill bits and stuff will only allow you to get so close, so get as close as you can to those corners, and then run clecos as registers down the whole entire thing. So the clecos are all in there. I don't know why we put them in there after we drill, we just do. I think we'd probably find out why we should if we didn't do it. I guess just to make sure that they're going to go in place. But we'll take all the clecos out now, we'll pull that piece off. So we have it registered where it's going to go. Again, it'll go back in the exact same spot since we've done that. Again, here's my favorite tool. This is what I want to use to start getting this this loose. I'm going to go along and kind of just bump it with the back of my hand and loosen this up. That wasn't very... See how it just fits right in there. I want to get all these vertical surfaces loosened up first. And see how I can just start cutting down there, getting that loose. This thing's probably going to come right off of there. But really, really want to make sure that everyone understands not to lift this part, because you'll start disturbing this. It doesn't matter right now, but you just want to make good practice and always remember that. It's hard to remember all these sequences that you're supposed to be doing when you're doing this stuff, and you'll easily forget one. So just as practice, just always treat it like it's the mold, like it's something that has to be done in a certain way. Yeah. Okay, look at this. You see that little gap between there? Man, it's hard to, yeah, okay, there it is. That little tiny gap where this is pulled away from this part of the mold, the tooling that we used, that's how much fiberglass shrinks and moves. So this is one layer 3 ounce mat, one layer 1.5 ounces. So what's happening is, since we did a hard right angle, right here, this angle, this fiberglass is shrinking back this way. it's pulling itself in because this angle is shrinking. It never goes the other way. It'll always pull itself in. So whenever you're doing right angles, it's important to know that. This doesn't matter, but I wanted to show you that. It's something that happens with fiberglass constantly. If you don't want that to happen, you can put coring foam in here. And also people use wooden ribs. They'll laminate those in place to lock that. But you got to do it before you start pulling everything apart to start releasing it. But yeah, look at, that's super obvious how much it's moved. Where's that better spot? And it's not consistent either. That's the thing that sucks about it. There's some spots where the gap is bigger. See that? It shrinks up more. And then in some places, it doesn't even shrink up at all. So, other important stuff to know about fiberglass. We got the piece to release off of there really easily. It was super easy to do. Just to remind you guys, we pulled it from this direction because we were practicing not disturbing molding surfaces when we have seams. I got all of these register bolts for this piece of metal. I'm going to take all that off now. And I know the people that are watching that know how to build molds. You're probably like, wow, you're putting a lot of tooling marks in that plug, which we are going to get rid of them. So as we go through the process with the tooling marks, I'll show you how to get rid of them. It's not very hard at all. We just fill them in with some stuff before we make our mold. But we'll have to make some more registered marks when I make this side of the plug. So stay tuned. There is that petroleum clay we used. You can see it stayed right where it needed to. It kind of came apart right here when I pulled the plug off of it, but it gave me the shape that I wanted. It stayed in shape and form. This stuff's garbage now. If you want to start a fight in a molding shop, take this clay and put it back with the rest of the clay, and it'll make everybody in the building mad at you. Because what happens is if you get little chunks of stuff in there, I mean, just little dirt, anything, it doesn't matter. It will show up in your mold. Also, when you're trying to smooth it out, when you're making a silicone mold, you have to have your surfaces completely flat on the two where you make the seam for the part. It's called the part line. And you kind of just like smear that super smooth with all these different techniques. And man, if you have a little piece of dust in there and you go to smooth it, it'll take a chunk out and it makes everybody so mad. So sometimes you get to reuse it, sometimes you don't. So if you have it in a dirty, dusty environment, don't put it back with the rest of your clay. And I know it's funny, I showed you guys like a really dirty block of clay. And it's just because it's been sitting around here so long. And I'm using it for this stuff because it's not as critical to be as clean as that. So yeah, toss that in the garbage. We have to prepare the surface to put the plug back on. So just clean it up like that, get all that stuff off there. You'll see how uneven it was. The surface was as you go through of the old part line where you took your plug off and scrape all that stuff off. I just scraped a bunch of it off there and I was like, oh man, I should have showed everyone that. But you see right here, you can see how uneven the surfaces are versus when you get a molded surface, you can see they perfectly made up right there. This is the plug we made with the polyester high build primer. This is one of the plugs we made with the red tooling gel. What are the advantages and disadvantages of this? Well, this polyester primer is readily available anywhere. Usually you can get a high build primer at Napa or like an auto parts store. Generally they'll have a polyester high build primer. Tooling gel and gel coats, they're a little bit harder to find in some places. I live in North Idaho, so we don't really have a place that carries gel coats and composite stuff like that. We have to order it all. And but Napa has high build here, and so does the paint shops and the auto body shops. It's a little bit more cost effective too. What I like about it the most is it's very, very sandable. So you see this edge here that we did with the petroleum gel? It's nice, but it's not that nice. So I'm going to take a piece of sandpaper and I'm going to sand it. I need this to be square. We can't round that edge off. If we round that edge off, the other part of the mold will have a pointed spot. So if we round this, the other part will be pointed and it'll be very fragile. So we can't round that edge off. You can make a master out of it a lot easier. If you wanted to sand this down and then re-primer it, change the shape of it, it's easier to do. You can do that with red tooling gel, but you'll have to add waxes to it and stuff like that. And generally it just doesn't work very well. Red tooling gel is a really, really hard material, so it doesn't sand as well either. I think I already said that. I'm kind of being redundant now. I just, if you're making a plug, I prefer polyester primers. So that's pretty much it. It's readily available, super easy to work with. Yeah, that's about it. So this corner wasn't the way that we wanted it, like I said in the other part of the video. It's square, but it's still got a little bit of defects in it. Here's another little pro tip. A lot of people use guide coat. I don't know if you guys remember the guide coat from the first videos, but if you first start sanding something, the material will be a guide coat naturally. You see the darker areas versus the parts that are sanded? Those darker areas are all the low spots. When you get into like wide block sanding and stuff like that, or you're looking for little scratches, guide coat works good, but you don't need to guide coat everything. So I already know what I need to do to that edge. See that little chip there? Yes. Check this one out. Already sanded it down, didn't get any breakthrough. It blocked out really, really well. That's a really cool thing about polyester high build. Using it as, I don't know, people call it infusion now, infusing high build primer to resin and matte. I don't know, we used to call it impregnation, because the resin impregnates the matte. So within the past couple years, I've started hearing everybody say infusion. And I think it's because it just makes it sound cooler. But I guess I'll just start saying it anyway. When you infuse polyester resin or polyester high build primer with matte and resin, you get a material that's easier to sand and easier to work with. And you can just shoot something right over the top of it. Like if I wanted to fix that, I could just put a little bit of Bondo or Cabosil in there, shape it out, and then just go ahead and sand it. Make sure you're completely de-waxed, because this was covered in wax. And then you can just shoot more primer on it. Make this a master a lot easier. You need to pay attention still to the edge right here. This part, you can see as we go down, you see how it's got a little raised rounded spot there. You need to get rid of that. That's really fragile. It'll bust off of there. You try to get that when you're doing the plugging, but it doesn't work all the time. So you just come back, so you just sand it off. And every time you make another copy of this, you're just refining it and refining it. So this is just bleed out from the wax drying. The wax that was underneath the metal on that radius, it dried and shrunk up on us. So that's how that happened. And just sand it off now, and you'll get, this thing is going to fit so perfectly when we put it back on there. Like I showed you the red one earlier in this video. You need to get rid of that stuff though. It'll cause problems in your tooling. A little industrial secret that I learned. I said, and I think it was either this video or the last video, that I spent some time, a couple years, working for a rapid prototyping company in which we made silicone molds and 3D printing and mold injection plastics and stuff like that. But mainly the people in the industry, they were old toy makers, like the kind of people that made action figures and toys in the 80s. And man, it was cool to work with them. So you get to learn all this stuff. So this chemical that I'm using, it's proprietary. I'm not going to tell you what it is. But I learned that from these guys, how to mix this up and how to prep and clean the surface super fast. I don't know if you can see it or not, but man, it cuts through that wax super fast. What it does is it cleans the wax off, but it's also a mold releaser. So it's pretty neat. The only reason I'm telling you this is because when you work in an industry, it's very, very important to explore all other industries. So what'll happen in this industry a lot, in the mold making industry, boat shops, aircraft companies, they'll start doing everything in-house, and they think they know everything, but they've never actually gone and talked to anyone else that does it. And you'll learn so many things from so many different people. Like I said, just even talking to seamstress about how to put your cloth down and your material down. You can learn so much from them because they work with fabric all the time. And then toy makers, I learned more from them than anything. I worked with some people from the boat industry as well. I learned some stuff from them, but the most beneficial ones I would say definitely were old toy makers from the 80s, the early 80s. So this is a cleaner. And somebody told me one time, every time you think you come up with an idea, something new of how to do this, somebody's already done it 30 years ago. And that is so true. I've so many times thought I've come up with a new way to do something, or like an innovative way, and then I'll go talk to somebody else in a different shop, and they'll be like, no, we've been doing that for years. Gary started doing that in the 70s. So it's interesting stuff, man. When you're making molds, everything constantly changes. You'll learn new things that weren't in your head when you started to make it. So here's one thing that is really, really important for me to pay attention to and to recognize that it's happening. For one, real quick, I did drop that and I chipped that. So anyway, this piece right here is locked in with this. When we put those registers in, when we were milling these pieces down, you see how we have them right here? That's a raised piece, and that's so when our mold goes together, it will lock in place on these registers, these little dimples right there. Well, this piece is going to have to be removed when we make our new plug. We're making our master plug for our mold off of this piece. The whole process starts all over again. One thing that I do need to notice and that I need to pay attention to is it locks. It doesn't want to come up. It can come out this way, but it's such a good fit, it won't move once it's in place. When I go to remove the master plug that I make off of this, I'm going to need to grind off this seam on the edge here. Where is that? See that? I have to take all that off the master plug because it makes that seam move. You can't really see it that well, but it makes it move just a little bit. And when we're making our mold and we go to pull this apart, it'll flex that flange and make it move. So when you're making molds, fit everything, pay attention. Let me get that where it needs to go. There it goes, right there. See, it just moves that a little tiny bit. That's enough to disturb your molding surface. It'll make an uneven surface between your seams if you don't get that ground off of there. The plug for the seam has been put in place. We've chemically treated it for a releaser. And it's going to be the same process again. We're going to make another plug off of that, just like we did with these. So kind of a redundant process. A lot of really good information in all of this stuff, though. So thanks for watching. Let me know if you guys have any questions. Like and subscribe to our page, please. We'd like some support. We'd appreciate any support. And I hope you guys are having a good weekend. See you next time.